Okay, so perform the indicated algebra. All right, so all common factors canceled. And assume that h is not equal to 5. Okay, so I'm going to give you about a minute and a half to work on this because that's about how long you would have on an Are You Ready test. And this really just has to be something that's very, very automatic. So there you go, 90 seconds. And that is a 5 in the denominator. Let me just make that a bit clear. That is square root of 5. Oops. You can't really see the screen? Are you saying it's too small, Sophia, or because I actually did just accidentally block it out for like a second? If it's too small, I think in the future I can kind of just do this maybe during the timers. That'll be a bit bigger. All right, so let's do this. So how do you go about actually simplifying this? So what would be your first step? It's blurry, but I think I accidentally was answering an email and then it kind of blurted out for a second. All right. What is our step? Multiply by the conjugate, right? We multiply and divide by the conjugate, right? To make sure we do not change the expression. So I'm multiplying both top and bottom by square root 5 plus square root h. Okay, and that helps us. So when I multiply out the denominator, when I multiply out the two factors in the denominator, what do I get? And also, what are we taking advantage of? Right, so we get 5 minus h. What identity are we taking advantage of when we do this, when we use the radical conjugate? We're exploiting a very common identity. Right, difference of squares, right? This looks like a minus b times a plus b. So it should end up being a squared minus b squared, right? Okay, good. And now the numerator, I have 2h minus 10 times square root 5 plus square root h. And now there is an error somewhere in here. So what is the error in my work? See, this is tricky, Dr. G. This will happen fairly often in this class where I write something and then actually it was wrong. Parentheses, parentheses, good. So this was kind of an introduction to that, not too hard to identify. So make sure you actually have parentheses around that 2h minus 10, or else you do have it wrong. Okay, cool. All right, now what can we do? Factor. So I'm going to factor exactly what are you actually factoring? Factor it 2. I'm actually going to factor out a negative 2. Only because I want it to look like the denominator. So I'm going to factor out a negative 2. And that means I'm left with 5 minus h up top. And because h is not equal to 5, I can cancel those factors, right? And then I'm left with negative 2 times square root 5 plus square root h. And we're all done, right? There's no more factors to cancel. All right, let's continue with the algebra. I'm trying to get in a lot of examples today because this is supposed to be review. Factor completely. Okay. So factor that completely. Again, I'll give you about 90 seconds to do that. All right, let's look at this. Okay, so how do you want to start factoring this? What's the first factor you tried to take out? Get rid of a negative exponent. Okay, so we definitely want to factor out the negative exponent. So Swarnam said factor out negative x to the negative 1/2. Peter Meehan said x to the negative 1/2. Okay, good, right? So in general, whenever you see an expression like this, where you see a whole bunch of powers of x, what is the general rule? You always want to factor out the least of the exponents. So actually, let me write down that general rule. So in this case, the least exponent is negative 1/2. Right, negative 1/2, 1/2, and 3/2. So I'm factoring out x to the negative 1/2. Now I'm supposed to be left with 3 terms, right? So when I factor out x to the negative 1/2 from the first term, I'm obviously left with just 3, right? I mean, but now let's look at the other ones more carefully, right? What happens if I were to factor out x to the negative 1/2 from the middle term? What does that leave me with? Right, 4x, right? How do you actually figure that out? Well, whatever you're factoring out, you subtract that exponent. So I'm subtracting a negative 1/2 from 1/2, and that just gives me 1, right? 1/2 minus negative 1/2 gives me 4x to the power 1. And then what happens when I factor out x to the negative 1/2 from the third term? What am I left with? X squared, right? Again, you subtract the exponent, right? So 3/2 minus a negative 1/2 gives me a 2. And as a sanity check, if you're not sure about that, you can always distribute the x to negative 1/2 back in and see if you get back the original, right? Because I think that's a more familiar rule to a lot of people, right? Adding the exponents. Or any event, now I have a quadratic, and that should be factorable over the rational numbers. Can anyone factor that over the rational numbers? Let's see, I think you're correct. X plus 3, x plus 1. Yeah, that's correct. And that would be what I consider to be fully factored, right? Or completely factored. All right, let's do one more with algebraic expressions. So simplify the following algebraic or difference quotient. Simplify. So I want you to simplify f of x plus h minus f of x all over h. And I'm telling you that f of x is, let's say, 1 over 2x. And also assume that h is not equal to 0. So simplify that expression as much as you can, given that function. I'm going to give you a little bit more than 90 seconds this time, since it is a little bit more complicated. I'll give you 2 minutes and 15 seconds. The answer should, sure, factored form. Yeah. Just as long as the h gets canceled, that's what I'm looking for. All right, so let's look at this. So this type of problem asks, if you did pre-calculus here, you probably would have done a lot of these types of problems. They're very important for calculus. So let's look at it. Okay, so first you have to kind of understand what a composition means, right? When I look at the expression f of x plus h, right? Let me kind of point out here some common mistakes I see. So a lot of times I'll see students write things like, oh, f of x plus h, that's f of x plus h, like that. That's incorrect, right? Or I'll see students write f of x plus h is f of x plus f of h. That's also incorrect, right? F of x plus h really means I look at the original function f, and wherever I see an x, I put an x plus h instead, right? It's function composition. So here I get 1 over 2 x plus h minus 1 over 2x, and then this whole thing is all over h. Okay. So I just highlight that. So this orange term, f of x plus h, that has become this term, right? So it's function composition. All right, so I'm just going to actually put this on the next line because I want to write a bit more here. Now, how do we actually go about, solving or simplifying this? Richard, I see you have a question. You just said how. I don't know what that means. If you want to clarify your question, so I'll keep going, and then you just want to clarify your question. So now we can actually simplify this. So there are a few ways you can do it. So I think the most common method that I see students use is you will focus on the numerator first, combine those two fractions, and then later combine the h into everything, right? My personal way of doing it is kind of skips a step. I think combining the numerator first and then putting in the denominator kind of, it's too many steps. I don't like that. So I want to kind of get rid of the middleman. So in other words, I'm going to skip the step where the numerator and denominator are still separate. I'm going to simplify everything. So to that end, what I do here is I consider what is the common denominator of everything. So I see three terms here, three denominators, 2x plus h, 2x, and 1. And what is the common denominator among all three of those factors? The common denominator is 2x times x plus h. So I'm going to be multiplying the top and the bottom by 2x, x plus h. All right, so what's going to happen here? So on the numerator, what's going to happen is, so this will get distributed, right? Because multiplication distributes over addition. And then this term will get multiplied into the h. So let's see what happens here. So on top, when I multiply out the first term, the x plus the 2's will cancel, and the x plus h's will cancel. I'm left with just x up top. And then for the second term, the 2x cancels, and I'm left with x plus h. So I'll answer that question in just a second, Chaya. And then down below, I have to distribute the 2x, x plus h. I have to distribute the h onto the denominator, right? So I get 2xh, and then x plus h, right? I have to distribute the h. Now, first, let me answer Chaya's question. So Chaya asked, how did you get 2x, x plus h? That is the common denominator of these three terms, right? 2x and 2x plus h. So there's already a 2 on everything. So when I combine these three things, I just need the 2, the x, and the x plus h. And now can you explain the third step again? No, you are going to explain it because this has two errors in it. There are two distinct errors. Keep in mind what I did, right? I have my common denominator over here, 2x, x plus h. And all I did, what I said I did was I multiplied everything out. But I did this incorrectly. I multiplied it out incorrectly. And I did it incorrectly in two ways. So Jitesh, you said need parentheses. Can you be more specific? Where do I need parentheses? On the x plus h. Okay. So one error is that x plus h better have parentheses. Okay, good. And there's a second error as well. Does anyone see it? Let's see. Karen, Alex, Emily. Okay, good. So a few of you said the correct thing. There's an extra h, right? This is a common mistake also. I see a lot of students sometimes when they distribute something with multiplication, they're overzealous. They kind of put the h on each term. But remember, it only goes on each term if you have addition, right? Not if you have multiplication. If you have multiplication, everything just kind of gets mushed into one big term. So there is an extra h, right? So I'm just going to erase that. So now everything should be correct. Any questions so far? This is also why it's important to make sure that you kind of follow along. And I did give you those 90 seconds or so to work on this. So you can also kind of see your work and see what I'm doing and kind of see exactly what the error is. All right, now the rest of the problem should be fairly straightforward. How did I get the numerator? So this was, I took my common denominator 2x plus h, and I multiplied that into each term, right? I'm distributing it across the numerator. So keep in mind that when I do that, when I multiply 1 over 2 times x plus h, when that gets multiplied by 2x, x plus h, what happens here? The 2's cancel and the x plus h's cancel. I'm left with just x. Okay. So let's keep going. So now let's distribute the minus sign. So x minus h all over 2xh, x plus h. The x's cancel out. Nice. And then we're going to see the h's also cancel out. Oops. Right, h is not equal to 0, so I can cancel out those h's. I'm left with just -1 all over 2x, x plus h. And so that's our final answer.
Never mind.
Never mind? Okay. All right, questions?